fantastic demo. I mean, sometimes you don't realize, how heavy a lift these guys showed in terms of how quickly the transformations happen, right? I mean, nodes coming down, nodes coming up, new services being invoked, moving from a cloud provider to another. These are, if you put a dollar value to some of the stuff that he showed, millions of dollars saved. Otherwise, these are projects that people execute over years and months, and with the kind of support or an army of people standing behind here, 3 guys or 2 standing and clicking around in the UI, and magic happens. So I think to showcase that, sometimes we ourselves don't realize the power of what is available, and what Dave and Matt showed is very inspiring even for me. So thank you, gentlemen. So with that, questions, shoot away. I don't have anything prepared to talk to you about. I've done my bit for the day. So if you have questions, we got going. Please.
You introduced some time ago the full text search capability. Do you officially pretend to be credible concurrent or substitute to more famous search engine like Solar or Elasticsearch?
The question is, you introduced full text search. Are you a pretender? Are you a contender? Are you a legitimate full text search provider? The answer is we are not directly, in one sense, functionally equivalent from the standpoint of a full search engine. The thing with the search engine is that typically your job out there is to go look beyond JSON. So that's about finding any kind of document and being able to find the text inside it. That's what a search engine is supposed to do. What we have done here is, at this point, limited this to just look within JSON and find the power. The JSON, what you have to realize, is a human readable document. So you can look inside that as though it's a Word document and do find, in which case it should be able to find the tokens anywhere inside the document. At the same time, JSON is a document which has got the schema inside it. So you should be able to do structured query in it, which is what David was showing a lot of it in terms of inventory, in terms of the types of food, British versus non, and all that stuff. Those are all structured query. Yet at the same time, you can search for banana and it could be sitting anywhere. It could be a comment, it could be in the order item type, anywhere. So that's where a search comes into play. So what we are doing with full text search is to be able for you to look inside a JSON in a structured manner with our nickel and introduce to that this unstructured querying or token-based querying. So this is what is called information retrieval, where you can look for a token like run, and ran and running, in other words, it's a natural language processing part of it, because it's the whole idea of search is to find meaning. It's called information retrieval. The query side is data retrieval. So what you do for that is you create an inverted index, which is doing the frequency counting and stemming and lexical analyzation. Whole pipeline is sitting behind it. That's what we've introduced. To answer your question in a short manner, it's not exactly a functional equivalence for Elastic up to a point, but there are a lot of similarities. And though Elastic can only do like a sort of a search type thing, in our system you can do both a structured query and a semi-structured or tokenized search. Does that clarify? Pretty long-winded way of saying that, yes and no. Please, his hand came up just a microsecond before you. We are very sensitive to performance here.
Enhance the NLP processors.
Yes.
Like that.
Yes.
Do you plan to do something similar?
We have just started to crawl. So when we walk, we will add some of those plugins and stuff. You will need some of those because, as you can imagine, you can do a lot of stuff with search in terms of plugins. You can do domain-oriented plugins. You can do language-oriented plugins. A lot of stuff is available there. That's the architecture is there in terms of what we build and how we support. We are a little bit away from there, but we will get there. Your turn.
If you elaborate a little bit on the legacy of, because document databases are not new. So there was
Mhm.
document databases before.
Mhm.
You can go back to Domino.
Mhm.
You can go to Couchbase, you can go to Couchbase, then Memcache comes in, you
Mhm.
build them together.
Mhm.
You add footage index, then you add analytics.
Mhm.
What is the natural evolution of building a stack on Couchbase? I mean, are you going to add applications later? Where does it end, or should it end?
No, the thing basically is, should it end? Yes, at some point. And where should it end? That we will leave to the customers and users, but it cannot just forever be going. But the point is that monolithic stacks and monolithic applications have their own sort of limitations. Where the layers have to consolidate, they haven't. Where they're sort of should, is what we are trying to achieve this year. Because if you really look, I use a simple example like an iPhone to demonstrate this. It's about 40 devices into one. So what happens? The cost of those 40 devices, if you bought separately, is like 10 times the cost of buying this iPhone. So the cost becomes cheaper, performance is faster, usability is way better. So that's what happens when you consolidate a set of technologies in tiers and bring them to one. We believe in this sort of a database which is interaction oriented or engagement oriented thing. You need a few technologies to fuse, and the value comes from there. We cannot just leave it like a regular database and do query here and create another search system and leave it there and create another analytics system. So there is a data pipeline that is behind, which is basically you start with using the system which is capturing, and then you query, then you search, then you do start to do some reporting, then it goes into the analytics side of it, and then you do recommend. That's the sort of operational analytics side of it, after which you can take this data to your data lakes, where you want to mix this data with other systems and find like complex event processing or complex pattern matching, if you will. So this event pipeline of a data is basically for us to provide that value to end user experience in collapsing times, basically. Because you have a search and a database in the same system, you don't have to create another connector to move this data. So the data is fresh when you search for it, and the information is consistent. And analytics, the same way, if you do it, then your time to insight should become seconds. What now takes in multiple instances, days even, if not hours. Because what you end up doing is that move this data to a, let's say, Hadoop or analytics system, which is a different programming model, and you batch it, move it there, do your intelligence gathering from there, and then push the data back into Couchbase. This is what we see many customers do. So we want to avoid that whole pipeline, having to learn two different programming models, move the data from one system to the other. If it's all in the same system, then you can find the insight within tens of seconds, or maybe even sub-second, depending upon the scale and size and stuff like that. So that's where the value is. So if you don't do this, what happens is that today you may be looking for something. Tomorrow, advertisers will tell you about, let's say you're looking for shoes today. Tomorrow you'll get recommendations for shoes on your browser. And you're like, why are they stalking me? The reason is they couldn't find that insight in time for you when you were really looking for shoes. And if you do that, that's when the value proposition begins. It's not about reporting that side of the equation. It's about being able to pipeline this data back into the application where you find. And you have to fuse these systems because you can, but more than that, because JSON is the document data model that we have chosen, which is human readable. And you have to take advantage of that. That's when you apply a natural language processing sort of techniques to it, you will find information out of it. Because prior to this, relational systems and all, there was no format. It was some binary representation of data internally. When you're getting this data in a format that is human readable and consumable, make use of that. At the same time, it's also sort of shipping you the schema every time. Make use of that as well. And the natural evolution of it is eventually get to the analytics, finding the insight side. And you asked the question about, do you go into the application space? Well, serverless programming is the next thing. So bring more logic closer to the data is always the way. So we will not perhaps take that on in the current manner that people think, but generally you have to introduce sort of eventing sort of techniques into the database tier, which will allow you to use old terminologies. It's triggers and stored procedures. But if I were to really do the marketing spin on this, that's your Lambda. So you can do your reactive programming. When the data walks in, you fire your logic and take action based on that. And that can be streamed out, piped, synced, operated upon, anything that you want to transform the data. You can do it in a sort of reactive programming manner. So we will build up to that point, keeping the edge to be on the server side, and the rest, because people have made investments in terms of what the application stack ought to be, and which could be Java or .NET or wherever. So we have to be careful in terms of sort of adhering to those and plugging into those, and not subsume it. Questions? More? Please.
Dave.
How do you see the growth of containerization in especially the cloud landscape as being relevant to the database landscape, especially in regards to scale and security and deployment capabilities and operational management?
That's a way of the future. We still believe a good chunk of the databases will perhaps be still done on bare metal. That's because they are very performance sensitive. But more and more of this stuff will happen in a containerized environment. And so far, the general evolution of containerization is based on this notion of stateless systems. So you can very easily scale or burst stateless systems, and that you can do with containerization technologies. The moment statefulness comes into it, containers are not in the best of shape so far. That's because there's sheer physics involved. When you're stateless, you can build everything stateless in the world except the database, because that's the one that maintains the state and gives meaning to all those stateless systems. When they come and discover themselves, where do they find their information about what should they be doing? That comes from a database. So now the database end of the world job is basically physics of moving the data in a reliable manner. But to do this in a container in a stateful manner is the difficult part right now. And there are stateful sets, sort of a concept that containers are introducing into this. And it's an orchestration tier as well as a container tier. Boundaries are there, which we want to make sure that they are in good shape before sort of standing behind that fully from a Couchbase perspective. People are running it right now. We are good. But when certain data volumes for certain sort of failure scenarios and recovery scenarios, it's not as robust as it should be. But it is getting there, and we are watching it. We are working with it. But we will definitely introduce that if things go well, maybe even next year kind of stuff. So it is the way of the future. And we want to be deployment model agnostic, which is it could be bare metal, it could be container, it could be cloud A, B, C. That's where we should be, because we should naturally plug into where people are running their applications. You cannot expect people to move their applications to where the database is running. That's my hope. So we should naturally plug into the places where people will be running their applications, and we should seamlessly and very easily be able to deploy, manage, upgrade, monitor, and the full life cycle of a database to be addressed in a containerized environment is the vision. The rest of the technologies have to be there. And as you know, there have been multiple stacks, OpenStack, not so OpenStack, Kubernetes, Mesosphere. That has to sort itself out a little bit too, because we can't spread ourselves thin by looking at the whole universe. But Kubernetes seems to be, I don't know what is the tier above that, which is going to win, but because each cloud platform has its own thing, and there are Terraforms, other stuff coming over there. But Kubernetes at least is the orchestration tier sort of leader, perhaps with the kind of support. Even guys like Mesosphere are actually supporting Kubernetes now more than their own proprietary ones. So we will continue to sort of innovate on that space. One last question, perhaps, because she's saying I'm already over the time. So, one right there, he's standing.
Can you talk a little bit about Couchbase Mobile and what's coming and where you see, or how you see the mobile landscape changing from mobile 1.4 to, I know 2's coming out. And I I've heard there's a lot of different performance things in there, and with Sync Gateway, especially, it's using MapReduce. Is that going to be changed to use like GSI or take advantage of Plasma?
Yes.
Or things like that are coming?
Yes, definitely. Where is Wayne? He can answer some other stuff, but let me answer to the extent I can. That's generally the plan. We want to introduce a lot more functional capabilities as well, like search and nickel equivalents on the edge, on the device as well, so it's easy to program to. But beyond that, we definitely are we will be working on exactly the points you raised about our indexes that are built on Sync Gateway or old views-based indexes. We want to move that to GSI and nickel oriented. So that should speed up a lot of stuff on that front, both scalability-wise as well as availability-wise. So that you should definitely expect in the near future. But beyond that, there are a lot of innovation to be done on the sync as well as the light database, to the extent that we want to even explore what is beyond the device. The edge is getting more and more edgier. So what should be, is there a smaller form factor that we need to be fitting in? And that's exploratory right now, but we are thinking beyond just what you would consider an edge right now, which is a device. The device form factor could be even smaller, micros and minis and whatnot. So we will innovate on that front. Idea is to move data, as close to where the action is, and bring as less data as possible to the cloud, because you want to find the information there and push it back. Otherwise, mobile strategy is flawed if you're going to move all the data from the edge to the cloud and then do something there. Your job should be to filter out the data that is noise, because if a signal, if a sensor, all the sensor is going to do is every second or so wake up and say, I'm alive. If it doesn't do at the right interval, that's the signal, which is to say somehow it is not saying I'm alive after the 1 second interval. That is the information that pattern is what needs to go up to the server. So the filtering that out from all the way to the edge to the cloud is where the rest of the magic is. So that's where all the innovation would be. Fantastic, people. There's one hand coming up. Okay, let me see if I can address this one in 1 minute and we'll wrap it up. Wait for a second. She's making all the effort.
So something I've been thinking about since morning is that I get the idea that we're trying to completely work off of the memory, trying to keep as much data as we can in the memory. It's faster to query, faster to everything. But I see a scenario where the amount of data coming in might be higher than the rate at which we can persist it to the disk. Mm-hmm. This is especially, we're talking about Docker containerization and putting stuff on the cloud, and mm-hmm. especially on the cloud, you can't be sure what kind of storage solution they have. It could be a networked storage solution. It could be, if you're bare metal, you have your own hard disk and stuff. But the servers could be several. Mm-hmm. So the amount of data coming into my Couchbase cluster could be infinite, mm-hmm. theoretically. But the rate at which you can write it to disk is not. Mm-hmm. You're smiling, so you've thought about it. So, of course. But my question is two-pronged. One is, as a systems engineer, I'm not able to think of a solution to this. I'm not even sure if it's solvable. As an application engineer, my question is, how do I protect my application from this kind of an edge case scenario? Mm-hmm. What do you propose?
So as far as the infinite capacity of stuff coming in thing, it's a question of how you set up your system, so to say. But the biggest benefit of having a horizontally scalable system like this is that you daisy chain more capacity, and that's how you can we have customers sort of who are doing 8 million ops per second kind of stuff. So imagine the kind of processing and the kind of data that is coming in. The second is, in terms of storing it on disk, is slow, agreed. That's why we are a memory-first architecture. We will persist it eventually onto the disk. You don't have to worry about it. You don't have to wait for it. That's what happens in traditional databases, that it has to hit the disk before you actually get. Here you don't. You have further sort of late binding principles where you can leave the system to manage it, or wait until it hits the disk, or wait until it is replicated. So these days, the progress is so much on the network front that accessing that memory across the network is faster than hitting the disk, right? So that way you can scale. You can scale horizontally by adding more capacity and daisy chaining. And if you have the right network bandwidth behind it, then you will infinitely scale, right? So that is the first thing. Disk is necessary because persistence sort of comes from there. There also there are enough advances, SSDs and stuff like that. So the drain rates into the disks are also advancing tremendously. So at this point, with the sort of innovation, there is non-volatile memory coming. So you're not even worried about the fact that you'd hit the disk, because even if you switch off, the stuff remains in memory. So we work with Intel in terms of the advances that are happening over there. So world is changing. The sort of assumptions or the sort of theories we are taught in schools are also changing now. But if you think disk, I don't have a timeline, but pretty quickly disks will be showing up in computer history museums, right?
But
So
my budget is still limited, so I can't afford.
true, the
all of that.
cost will also come down, right?
So how do I? Okay, I got it. How do I protect my application from a scenario like this? How do I detect that Couchbase my cluster might be struggling with the disk I have in place currently, and what software? Maybe I should come to you after.
Yeah, you can. But basically, it's about, like I said, the application needs to be split in such a fashion that you can infinitely scale. That's how you architect it. So you can. It's a problem that has been solved, but it's a problem that will continue to get solved based on people's needs. So modern architectures help you for this infinite capacity and how to scale it. Thank you, everybody. You can always find me with any of your really esoteric questions which you don't want to ask in front of everybody.